Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are focusing on sketching different kind of curves, and in particular, we are focusing on exponential function. Now, you hear these words growth and decay with respect to exponential. So now, if we look at the syllabus, topic 2 is algebra in graphs and the subtopic is 2.11. So let me highlight this one. We have to recognize, sketch and interpret graphs, and our focus is on this exponential function that is written of the form y is equals to a constant raised to power of x plus another constant. So m is a constant, c is a constant, x is the power, also known as exponent, hence the term exponential, and y is a variable. Now they are interested in knowledge of turning points, if any, vertical and horizontal asymptotes, if any, roots and symmetry. And then if we are talking about quadratics, we can talk about the turning points and so on. Now first of all, let's look at this power function. Let's look at this exponential function. So y is 2 raised to power of x. X is the power over here. Now let me plug in different values. First of all, let me plug in 0. 2 raised to power of 0 is 1. That's the basic rule of indices, which is a power 0 equals to 1. So therefore 2 power 0 is also 1. So I have written this over here. Now let me plug in values over here such as 1, 2 and 3. 2 raised to power of 1 is 2. 2 raised to power of 2 is 4. 2 raised to power of 3 is 8. And then let me plug in the value negative 1. 2 raised to power of negative 1. 2 raised to power of negative 1 is not negative. It is 1 over 2 raised to power of 1, which is 1 over 2. So when x is negative 1, y is 2 raised to power of negative 1, and that is what we get. So we get a half over here. 2 raised to power of negative 2 is 1/4, and hence we get this 1 over 8. So what do we observe? We are getting small values over here. We are getting values greater than 1. And then we are also getting a 1 over here. I don't see any negative. I don't see any zeros. That means 2 raised to power of x will always be positive. 2 raised to power of x will never be 0. 2 raised to power of x will never be negative. It will always be positive. So now let me sketch this graph, but before that, let me do one more thing. Let me focus on 2 raised to power of negative x. Again, if I plug in 0, 2 raised to power of 0 comes out to be 1. The negative has no effect. And then 2 raised to power of 1, because there is already a negative sign. So this is 2 raised to power of negative 1. So when x is 1, y is 2 raised to power of negative 1, which comes out to be half. So this is half, this is 1/4, this is 1 over 8. Similarly, if I plug in negative 1, so x is negative 1, y is 2 raised to power of negative 1, which is 2 raised to power of 1, which is 2. So we get a 2, we get a 4, we get a 8. Now look at these numbers. Look at these numbers and compare it with these. Over here, 1, 2 and 3, they were giving me 2, 4, 8 respectively. Over here, it's the opposite. Negative 1, negative 2, negative 3 is giving me 2, 4 and 8. In 2 raised to power of negative x, 1, 2 and 3 are giving me fractions between 0 and 1. Over here, negative 1, negative 2, negative 3 in this function, when plugged over here, they are giving me fractions between 0 and 1. So this is kind of flipped. The blue ones are now on the other side, the red ones are on the other side, and this is standing in the middle. So now, first of all, focus on one other thing also. Let me write these numbers. This is 8, 4, 2. There is a 1 over here, and then there is a half. This is 1/4, and this is 1 over 8. Similarly, focus over here, we have 1 over 8, 1 over 4, 1 over 2, then there is a 1 over here, and then I have 2, 4 and 8. Now my question is there a pattern to it? Is there a sequence to it? Not necessarily a linear sequence or an arithmetic sequence. Yes, this is a geometric sequence, which some people study in AD maths, some people study in AS level maths, and so on. Yes, it's a geometric sequence because there is a constant multiplication by 2. So multiplication by 2, 1 over 8 becomes 1 over 4 and it becomes half, and then multiplication by 2 gives you 1, multiplication by 2 gives you 2, and so on. Over here, it's the opposite. Over here, yes, I use the word multiplication, and yes, it's multiplication by half. Over there, it was multiplication by 2. Over here, it's multiplication by half. So multiplication by half, and so on. Therefore, 8 is becoming smaller. Therefore, it's a scenario of decay. Over here, 1 over 8 is getting bigger. So therefore, it's a scenario of growth. Hence, this is a graph of exponential growth. And over here, this is a graph of exponential decay. Now, there are two aspects to this particular thing. When we talk about exponential function, we have to talk about the sketching and taking care of everything related to sketching, and then there will be some word problems, something similar to compound interest. So now I'll be making a separate video on this one, and over here I'll be focusing mainly on sketches. So now it's time to sketch this thing. So let me go back all the way to the top and let me grab this thing and let me make it smaller and let me copy paste it over here. So first of all, copy, and then let me take it down over here and let me make it smaller. Okay, so this is 2 power x, and then there is 2 power minus x. I'll just flip it. So now let me mark this thing in green color. Let me mark this thing as 1. So this is 0, 1. That is this value I have labeled. And now 1 is giving me 2, 2 is giving me 4, 3 is giving me 8. So with a blue marker, let me draw it like this, something like this. Let me make it a bit thinner. So it's going like this. That is for this region on the right of 0. And then on the left of 0, the numbers are smaller, but they are getting very close to the x-axis, but they are not touching it, something like this. Okay. So now this is causing a bit of trouble. Let me remove this one, something like this. Okay. And let me make it a bit thicker. No, not like this. Okay, that looks better. So now what do we observe? The graph gets very close to the x-axis but does not actually touch it. So such a line is called an asymptote, which means graph approaches a particular line, which in this case is what? Which in this case is the x-axis. And what's the equation of x-axis? Y is equals to 0, but does not touch it. So such a line is called an asymptote. And since it's a horizontal line, so we use the word horizontal asymptote, and I'll also use the symbol HA, horizontal asymptote. So yes, there is a horizontal asymptote, and which is x-axis, which is y is equals to 0. And the other thing that's prominent over here is the y-intercept, which is 0, 1. So therefore, whenever we draw the power function 2 power x, take care of the y-intercept, which is 0, 1. Take care of the horizontal asymptote, which is y is equals to 0. And these are the basic things that you need to take care of. Now, 2 raised to power of negative x, what will happen? So let me just grab this thing and let me draw something like this. Okay. And let me mark this thing and let me go up like this. Okay. So now over here, this is 0 is giving me 1. So this is not drawn to scale. This is a sketch. And the red part that was on this side, now it's on this side. And also let me grab the, what you call the table from here so that you can have a good look. It's right over here. And it's copied. And let me paste it all the way down over here. Let me make it smaller. Okay. So now you can very carefully see this thing. Let me erase all the extra stuff. And let me stroke eraser is good. Okay. And let me also clear this thing. Okay. So now this one is the graph of growth, exponential growth. This one is the graph of decay. And again, the obvious points are what? There is a y-intercept which is 0, 1. So this is 0, 1. And there is still a horizontal asymptote. It gets very close to the positive x-axis, does not touch it. That is y is equals to 0. So yes, there is decay and then there is growth. So I hope this is all good, all clear. You can also acknowledge it on the WhatsApp. So now y is equals to a power x. First thing first, the base that we talk about, that is a positive base. Base should not equal to 1 because 1 is a useless number as a base. Why it's useless? Think about it. 1 raised to any power will always be 1. That is why it's a useless number as a base. And y is equals to a raised to power of negative x. This is a still positive and a should not equal to 1. And what else is there? This is a graph of growth and this is a graph of decay. The growth could be about the growth of bacteria, the growth of human population, something like that. And the decay could be about half-life of radioactive materials. Physics is there. So now one other thing. If I write a raised to power of negative x, can I write this thing as 1 over a power x? Of course I can. And 1 raised to any power is 1. So 1 over a x can be written as 1 over a whole thing raised to power of x. That means y is equals to 2 raised to power of negative x. It's 1 over 2 power x. It's half raised to power of x. So what some people do is that they write things as this. Let me make a box over here. Let me make another box over here. Some people, they also prefer to write it like this. Y is equals to a power x and a is greater than 1. This is a graph of growth. Y is equals to a power x and a lies between 0 and 1. This is a graph of decay. Because if a is a fraction between 0 and 1, so basically a power x for this thing is the same as what? Y is equals to a raised to power of negative x. That's one thing that you should remember. Now let's draw some sketches. Let me get my marker ready and I'll just be using a single color. So first of all, 2 raised to power of x with a negative sign. 2 raised to power of x with a negative sign. What is the function of this negative sign? This is reflection in x-axis. That is very basic thing that we have learned in quadratics and so on. So let me draw the original one. So the original one goes like this. And let me use this thing. So the original one is going like this. And the translated one. So let me just do one thing so that the colors are not mixed up. So over here, this is a negative sign. And let me use green color for that reflection. So that goes like this. And let me draw it in a blue color. So therefore, or green color is good. So therefore, this goes like this, the marker thing, okay, and like this. So let me just do the adjustment. I think it is pretty good. And let me just take this down like this. Take this down like this, okay. So now this is not an exact drawing. This is not graphing, this is sketching. So first of all, this is 0, 1. what will happen to 0 comma 1? This becomes 0 comma negative 1. This is y is equals to 2 raised to power of x. This is y is equals to negative 2 raised to power of x. And the asymptote is the same, which is y is equals to 0. That is the horizontal asymptote. Similarly, 2 raised to power of negative x. 2 raised to power of negative x, it goes like this. And let me draw its image like this. So therefore, let me label it. This is y is equals to 2 raised to power of x with a negative sign. And this is y is equals to negative 2 raised to power of negative x. This negative over here, that is again reflection in x-axis. So this was a graph of decay. So this is a graph of decay. This is a graph of growth, and that's how it's drawn. Now keep in mind, it doesn't make a difference what the base is as long as it fulfills the criteria. So if I were to draw y is equals to 3 raised to power of x, it would still look the same. If I were to draw y is equals to 4 raised to power of negative x, it would still look the same, except it would be a bit steeper. But for sketching purposes, it doesn't make a difference. Okay. So now let's do some translation, some vertical shifting up and down. So y is equals to fx plus k. It is a vertical translation, like the translation that you study in transformation. And if it's a minus, so let me just use this color. So first of all, let me use an eraser, a plus k, and then a minus k. So if I have plus, it's a vertical translation up. And if I have negative, it's the same vertical translation but down. So 2 raised to power of x plus 1. Now what will happen? Just focus on that. Let me draw the original one again like this. So that is the original one. And remember that the asymptote is y is equals to 0 and the y-intercept is 0 comma 1. Now if I want to draw the plus 1 thing, so what will happen? Draw a graph parallel to the original as good as possible. Don't aim for perfection, because in life you never achieve that. So if I add this plus 1 over here, what happens? The y-intercept is increased. So 0, 1 becomes 0, 1 plus 1, which is 0, 2. And what happens to the asymptote? So the asymptote also rises up by 1, and that is what the examiner is interested in. So always study from the perspective of this examiner, and definitely for the purpose of knowledge also. So now the new y-intercept is 0, 2, and the new horizontal asymptote is y is equals to 1. So this purple asymptote is for the purple curve. The black asymptote is for the red curve. All good, all clear? 2 raised to power of x minus 1. Now let me get my red color. Yeah, that's the original one. Let me get it ready like this. And then let me shift it 1 unit down. So now let me choose which color? Again, purple color. Okay. So now it's like this. Let me just adjust it a bit. And I hope you have understood why did I adjust it. This is 0, 1. This is 0, 0. That is the new one. So new y-intercept is 0, 0. That is y-intercept. And what about the horizontal asymptote? Originally, the horizontal asymptote was y is equals to 0. Now it's what? This one is, let me get the marker ready. This one is y is equals to negative 1. Y equals to negative 1. Y equals to negative 1. All good, all clear? Just have a good look. So now this one is 2 raised to power of negative x plus 1. So first of all, let me draw the blue curve like this. And let me make it more slanted, something like this. That's good. And let me just copy this and paste it below. I think it's the same one, if I'm not mistaken. Yeah. So, okay, that is good enough. And then I'm drawing what? I'm drawing plus 1. So let me draw it in green color. And it's going like this. And let me also draw it in green color. And that is like this. this. Okay. So let me just do some adjustment like this. No, that doesn't look good. So, there it is. Okay. So now this is like this. Okay. As long as it's not touching, it doesn't make a difference. So first of all, this is 0, 1. Now it's 0, 2. So y-intercept 0, 2. Over here, it is 0, 1. This is 0, 0. And y-intercept is 0, 0. As a coordinate, I've written it. Okay, what else is there? Let's talk about the asymptote. So now the asymptote also rises, and let it not touch this thing. So precision eraser, and just show it like this. So this is y is equals to 1. Originally it was y is equals to 0. Now it's y is equals to 1. Originally it's y is equals to 0, and now it is y is equals to negative 1. So this is y is equals to negative 1, horizontal asymptote, y equals to negative 1. So horizontal asymptote, all good, all clear. Now what about this? Minus 2 power x plus 1. Minus 2 power x is somewhere over here. That's the one. Minus 2 power x, that is this one, plus 1. So first of all, you have to think a bit. This is 2 power x. This is y is equals to minus 2 power x, and then you are adding 1. So first of all, let me draw this thing. Green color, marker. This is negative 2 power x. This is also negative 2 power x. Both things are drawn. And then first one is plus 1. So let me draw it like this. Actually, let me just copy this. Of course, that I can do on my iPad, not on the paper. Let me paste it over here. And let me just change the color. No, not take screenshot. Just change the color to purple. Okay. And the same thing over here. Negative 2x, negative 1. Something like this. And change the color to purple again. So now let me write it down. First of all, the original one is y is equals to negative. This is y is, that marker is thick. Hold for a second. Now this is y is equals to negative 2 power x. This is y is equals to negative 2 power x plus 1. This is y is equals to negative 2 power x. This is y is equals to negative 2 power x negative 1. Got the idea? Now let's mark the asymptotes. This is 0, negative 1. This is 0, 0. You can write it yourself. This is 0, negative 1. And this is 0, negative 2. What about the asymptotes? Let me mark that in red. So I'm drawing the asymptote for the transformed one, which in this case is the purple one. So therefore that is over here. That is 1 unit above this thing. So y is equals to 1. So horizontal asymptote, y is equals to 1. Over here, it's gone down. So this is this thing. And over here, it's this thing, y is equals to negative 1. Horizontal asymptote, y is equals to negative 1. I think it's all good, all clear. Now what if I multiply a constant by this exponential function? So now this intrigues people a lot. First of all, I would like you to plug in x is equals to 0. So f of 0 is 3 into 2 power 0, which is 3. So the y-intercept is 3. So y-intercept is changed. And horizontal asymptote remains the same. The same over here. Y-intercept will be changed. And horizontal asymptote will be the same. So now if I plug in x is equals to 0, f of 0, now 2 is outside, 3 to the power 0, this comes out to be 2. So they both are the same kind of thing. The steepness would vary a bit, but who cares? So now let me draw this thing like this. Let me draw this thing like this. It's the same thing. Let me simply draw the asymptote. So the asymptote is y is equals to 0. The asymptote is y is equals to 0. The y-intercept is 0, 2. The y-intercept is 0, 3. All good, all clear. Now in the latest specimen paper, if you look, they have asked for questions like this, especially the ones that you see over here. So now over here, because of this plus 1, now horizontal asymptote will be changed. Now because of this -1, horizontal asymptote will be changed. Now let's calculate the y-intercept. First of all, let me choose x is equals to 0. So f of 0 is 3 into 2 power 0 minus 1. That is 3 into 1 minus 1. That comes out to be 2. So the y-intercept is 0, 2. And over here, f of 0, that is 3 into 2 power 0 minus 1. That is 3 into 1 minus 1. 3 minus 1 is 2. So therefore, y-intercept is 0, 2. That is 3 into 2 power x, 3 into 2 power x. And 3 minus 1 is 2. And this is, I think there was a plus, my bad. Let me correct myself. 3 plus 1 is 4. And this is 4 over here. Okay. So now, what about this thing? First of all, if I focus on just this thing, isn't this the same thing as this or this? So the y-intercept was 3. Now it's 4. The horizontal asymptote was y is equals to 0. Now it will be risen up. So therefore, let me draw this directly. First of all, let me draw the horizontal asymptote. So this time a different approach, slightly. That's the horizontal asymptote. And let me draw this curve right over here. So now I can label it. This is 0, 4. And this is y is equals to 1. That's how you draw it. So maybe the examiner will ask you the whole thing. Maybe the examiner will ask you the y-intercept. Maybe the examiner will ask you the equation of asymptote. Over here, this is -1. So the asymptote has gone down by -1. So let me just draw this thing. Something like this. So this is y is equals to -1. And let me again draw this thing, something like this. So it's cutting at 2. So like this. It's cutting at 2. Let me make it thicker. Okay. So that is better. So this is 0, 2. And the new horizontal asymptote is this. What about this one? 3 into 2 raised to power of -x plus 1. So when x is 0, f of 0 is 3 into 2 raised to power of 0 plus 1. This comes out to be 4, just like the other one. Just like the same thing, but except for that it would have a decay thing. And since there is a plus 1 over here, so the horizontal asymptote will rise up by 1 unit. So let me mark this thing. That is the horizontal asymptote. That is y is equals to 1. Horizontal asymptote, y is equals to 1. And over here, now horizontal asymptote will be y is equals to -1. So now over here, this is horizontal asymptote, y is equals to -1. That is this thing over here. Because this thing over here, 3 into 2 raised to power of -x. Let me first show you. This is somewhere over here. Where it is? Yeah. 3 into 2 to the power x is increase, and 3 into 2 raised to power of -x, that would be a decrease. So I think I skipped that thing. So let me add a page. Let me add something from here. Okay. And there is another one also. Yeah. No, not this thing. Yeah, this one. So let me just adjust this thing. Okay. Now, first of all, I'll draw, and then you can have a good look. So let me draw this thing like this. And let me draw this thing like this. Okay. So now, y is equals to, fx is equals to 3 into 2 raised to power of -x. fx equals to 3 into 2 raised to power of -x. When x is 0, f of 0 is 3 into 2 raised to power of 0, which is 3. So now this is 3. So now the y-intercept is 0, 3, but the horizontal asymptote remains unchanged at y is equals to 0. Similarly, if I write fx as, let me put 2 on the outside, 3 on the inside, still it would be the same. Horizontal asymptote is still y is equals to 0, like this. And if I plug in 0, that is 2 into 3 raised to power of 0, which is 2. So this is 0, 2. So now I think everything is filled up like this. Okay. So now 3 into 2 raised to power of negative x. So let me draw it in blue color, and it's coming like this. All good. And similarly, minus 1, this would be coming like this. So the y-intercept initially was how? 3 plus 1 is 4. So now the y-intercept, just do with the calculation, that is 0, 4. And over here, when x is 0, f of 0, it's 3 into 2 raised to power of 0 minus 1. 3 minus 1 is 2. So let me draw over here, that is 2. Okay, so let me draw it a little bit up. So this is 0, 2. So there is a lot of variety in exponential and some extra stuff for you. Let me tell you what that extra stuff is. This diagram, we have already gone through it. Something like 10 raised to power of x, more steeper. Half raised to power of x is 2 raised to power of negative x. Let me write this thing again. A raised to power of negative x and 1 over a raised to power of x, it's the same thing. It's a graph of decay. In general, that's how they have written it. 2 raised to power of x is like this. 2 raised to power of x plus 3. Just focus on everything. We have done everything. This is for you, some extra stuff. 2 into 3 power x plus 1. We have done things like that. 3 power x, negative 3 power x would be like this, and then plus 2. Focus on the asymptotes. Focus on the y-intercept. Something for you to practice, because a lot of people, they ask, sir, can you give us some practice question, because this is something new in the syllabus. So those are the practice questions. The solution is right over here. Pause, take a screenshot, double check. But first you have to try it out. And some other extra thing. Now all this thing that is written over here, let me just erase this so you don't have to worry about this thing. That is this part, just erase this. Okay, just focus on whatever is inside the red box. So just focus on that. And let me just do the erosion process for you. Let me also erase this. It's very satisfying doing this thing. And of course, the satisfaction also comes when you make a difficult topic easier for the students, and then they praise you. And then they give you all the credit for the grades. Question 5, question 6, and all the answers are over here, and that is the end of the story of this particular topic that is about exponential function. Stay tuned for more content.